like to welcome you today to the Global Food Systems Feed Grant presentation series. Today, we'd like to welcome Dr. Caterina Scoglio, who's professor in electrical and computer engineering here at Kansas State University. Dr. Scoglio?
Thank you, Maureen. Thank you. And welcome, everybody. In this presentation, I would like to review together the results we had in our Global Food System Seed Grant. The title of our project was Increasing Safety and Trust in Beef Cattle Production. So safety and trust are the key words in this case. And to do that, we use the blockchain approach for sharing movement data. Okay, so the team I want to give a credit, I was not alone doing this work. I would like to mention Dr. David Amrine, co-PI from the Beef Cattle Institute in the College of Veterinary Medicine, K-State. Dr. Don Gruenbacher, also my colleague in electrical and computer engineering at K-State. Collaborator, Dr. Beatriz Martin Lopez from the Department of Medicine Epidemiology in the School of Vet Med at University of California, Davis. She is hosting me during my sabbatical. And the student, Tanvir Ferdowsi, now also Dr. Ferdowsi, who was really the main player in this project. He wrote the majority of the code, and it's important to give credit to his work. And so this was the team, and the motivation of our work was the following. The cattle farm industry in the United States lacks proper traceability, meaning that it's very hard to know where animals, cattle are coming from and going to. And why it is important instead to have traceability? For two main reasons. One, tracing farm animals enables effective disease control. We know now with COVID, for example, that we have been doing contact tracing. Same thing is for disease control for animal diseases. You want to know in case of detection of an animal disease, who are the animals that were in contact with that given animal before. And so tracing farm animals enable effective disease control. However, it's very important to keep data on farm animals and their movements confidential, because in all these, in the industry, in the agricultural industry, is very important to give the farmers the confidence that the data will not be shared and will stay confidential. And this is the first reason why tracing animals is very important. But the second one is instead even more important because it's something that can be used all the time. The first point can be used only in the case of a disease control. However, tracing animals can provide reliable provenance that can improve consumer trust, bringing premium prices. So if you can prove what was the history of that animal, which steps went through, which feed was used for that animal, you can impose higher prices on that, on selling that meat. So our project is not the first project trying to collect movement data. There is a project currently called US Cattle Trace that uses a centralized database to store cattle movement data. So there is a central authority in this project which collects data and put this data into a centralized database. Now, this project is managed by a group of producers. So the central authority is not governmental based, is still producers, but is a centralized approach. The US Cattle Trace was initially developed for the state of Kansas with the support from the Beef Cattle Institute at Kent State, and now is expanding toward many other states. So this project is gaining some expanding. The goal of our project was instead to decentralize the system management to enable cattle movement data collection without a central authority. So this is an important point. So there is no central authority that manages and is always the one in charge of the data. But here the system is, we wanted to have a system decentralized where all the users are owner of the data. And so what we wanted to do also was design a method to trace animals while protecting business identities and enable anonymous collection of summary data to share summary data with people belonging to the group. And so the proposed solution in the project was based on blockchain. Blockchain is the technology behind the cryptocurrencies like Bitcoin. But while Bitcoin is based on a public blockchain, what we focused for this project was a permissioned blockchain, where users are not everybody who wants to join, but needs to be part of the group to be part of the system. And people have different roles assigned based on their positions. And so summarizing what is a permissioned blockchain, it is an immutable distributed database. Immutable and distributed are two key words for these systems, where each participating user maintains a verified copy of the shared data, creating transparency. So there is no single person that has an advantage. Everybody is in the same position when participating to the blockchain. Even though, however, every participating network users executes and records the same set of transactions, so the data is available to all of them, not all transactions can be seen by all users. There are rules to define who can see what. So these rules, defining these rules was one of the main points of our project. A permission blockchain does not need any centralized authority. It is secured by design and cannot be altered by any single user retroactively, meaning that if there is a transaction that happened a few days ago, it's not possible to go back in the database and change, alter something of that transaction, because everything else that happened after that is based on that transaction. And so if you change it, it doesn't match anymore. Defining specific smart contracts, the users, which is the owner of the data, has full control over how his or her business critical information is shared with others. So if we want to summarize what are the benefits of a permission blockchain solution, these are the most important points. So provides an immutable database, removes the central authority, and is providing democracy to the system. Transactions and animals can be traced back efficiently, can implement and run policies, those smart contracts, in the form of computer code, and supports secure communication. Everything is secured and encrypted. So our project is not the first case of a application of blockchain. Actually, there is a lot of work in the industry to apply blockchain to supply chain into the food and agriculture sectors. For example, IBM with Walmart, the electronic health records, the reputation system for bannets, but also in the field of beef cattle, the beef chain approach in Wyoming. And so these are examples of use of blockchain in the food industry. So why it is important to record, to store the movements of animals? Because in the US, animals make a lot of steps during their lifetime. So they may be born in a ranch, they move to a stocker, and this stocker can be miles away from the ranch where they were born. Maybe in another state, and then they are moved to a feedlot to gain a lot of weight, and then finally to the slaughterhouse, and then to distributor and the retail. So each of these steps implies a movement. With trucks, these animals are moved very distantly. And one time we measured the amount of movement of the cattle is really amazing each day in the US. And so this is the scheme of our proposed solution. So the system operates on a peer-to-peer network protocol. So here is the example of a peer-to-peer network protocol. Each node in this network is a farm, and this farm can be in contact with all the other farms belonging to the system. Now, in each of these node is a network participant that can be a business owner, a farm owner, a feedlot owner, someone of this type. And a client node, so a node like this, contains two main parts. One is the Ethereum node. So it has the blockchain node. Ethereum is one specific implementation of blockchain. And the other part is the local database for the business owner. The Ethereum node includes what are called the smart contracts. So these smart contracts are the piece of code that provides those rules for belonging to the system. And so here are the 5 smart contracts used in the system, defined in our system. The farm manager, where a new farm needs to kind of refer to become part of the system. So a new farm is given maybe an ID, a password, a cryptographic key. Within a farm, there are all users, so they will use the profile manager to define all the user and their roles. And then there is a transaction manager with managed transaction between farms, so selling and buying cattle. The trace manager that collects all the movement when some cattle is sold or is transferred from one location to the other. The trace manager will collect the data. And the data aggregator, which will provide, collect data from single farms and provide an aggregated overview of relevant information relevant for the group. So this is an overview of our system. So an example of exchange of buy and sell cattle between 2 farms. Owner A is selling cattle to owner B. And so there are several steps that needs to be done. Create a transaction, verify the access level, check the ownership if really the owner of the cattle is owner A, and then update the transaction after this verification, transfer animal data, and then update farm info, add the movement data, because when we transfer the data, we add the movement data to the trace manager, and then add to the database the new animal in farm B and remove from the database of owner A. So these are examples of all the steps that needs to be done when there is a transfer of an animal, and the 4 smart contracts that are involved in these steps. So we did a verification of the system through a test bed with 6 nodes configured as in this figure. We use Ethereum clients. We use a consensus protocol proof of authority. So the consensus protocols is what happens among the node once several transactions are created. These transactions need to be verified and then approved and become a part of the blockchain. So there is a consensus protocol for this. Maybe you are aware of the consensus protocol of Bitcoin, which is the proof of work requires a lot of energy, power for computer determination of that proof of work. But in this case, it's much simpler. It's proof of authority. There are some players in the system that can provide the consensus and approve the transaction and become part of the blockchain. We did 10 integration test cases to verify the system. And so, for example, we did attempt legitimate actions or non-legitimate actions, and we wanted to make sure that the system was responding properly. For example, an authorized farm owner attempts to update farm info. If it is authorized, the result was positive. So the system responded properly and this action was done. However, if an unregistered user attempts to update farm info, the system will go into a negative response, not allowing this type of action. And so our tests were like this type of test to verify that what was possible to be done was done, but if something not authorized was attempted, that was blocked. And so, for example, registered user attempts to update the info at a farm that is not owned, negative. Authorized, the farm owner attempts to create a business transaction with another authorized owner, positive, because this is definitely a legitimate action. And registered user attempts to create a business transaction, negative, not possible because the user is unregistered. Only registered users can be part of a permission blockchain. If it is a public blockchain, everybody can be part, can be a user, but not in our system. The admin attempts to retrieve trace data, positive, it is possible, it works. But unauthorized user attempts to retrieve trace data, negative. Invited user attempts to submit survey data. This is for the data collection, positive, but unauthorized user attempts to submit survey data, negative. And the admin attempts to retrieve summary data, positive. So these are examples of actions that we tested in our system. So if we want to summarize what we think are the benefits of our solution, I think are these 4 points. First, it is possible to have information transfer along the supply chain to meet the consumer demand. This is very important. It's a kind of a verification and building trust with the consumer. And so premiums on produced beef can be shared with participating producers along the way of the supply chain. Analysis of reliable, anonymous, and aggregated data is shared in the platform, and the protection of animal is done in the case of an outbreak, since mitigation strategies are going to be more targeted. So now, if I want to compare the benefits of our solution with the benefits of a centralized solution like the other project that have a centralized solution, we can say that this last point is obtained equivalently in our case and in the centralized approach. However, these other 3 points are an additional benefit that a blockchain solution can provide. And so this is why we believe that while both approaches can provide good tracing of animal movements, the blockchain can have these additional benefits of providing this verification of history of the animal that can improve the trust, provide a way to increase the quality of the product, and also this analysis, the provision of reliable, anonymous, and aggregated data with this big data approach used in all the fields could be very useful also in our system. So the contribution of our projects are the following: proof of concept of the centralized data management system for farm animal supply chain using blockchain. So we did a proof of concept and we developed all the parts of the system. We designed the specification of how users, data, and communication are handled to maintain data ownership and user privacy. This is a very important point for the industry, that the owner of the data maintain data ownership and user privacy. And finally, an evaluation of the prototype system using integration tests under various operating scenarios. So the outcomes of our project are the following. We published a paper in the IEEE Access Journal. This paper attract the attention of a company, an Argentinian beef cattle consortium, green-fed. We were contacted and we worked with them for several months on an agreement in progress to start an industrial pilot project based on blockchain. They were impressed. They went to use the work developed in our project. So in this project, we also were able to support graduate students, Tanvir Ferdusi, Toman Malison, and Divya Vani Lakireddy, and one undergraduate student. And so we want to thank the Global Food System Seed Grant Initiative. It's been a great opportunity for us. And I will take questions if there are any, and also through my email, caterina@kstate.edu. Thank you.